The graph of the relationship y is equal to x squared minus 2 is below, showing it there. And they want to find out what is the domain and the range of this and put it in interval notation. Before we get into the problem, let's actually go back and review what domain and range is and what a function is. So if we take a look at this first one right here, state the domain, right here. State the domain and range of the following relationship. Well, a relationship is any set of ordered pairs. So it can be anything. It can be 2, 3, or whatever. Anything that has an input and an output. And so in this case, our input would be -2, our output would be 6. Here we input a 2 into something, and our answer comes out as 6. So the first one is our independent variable. So we can pick whatever number we want there. And the other one is our dependent. By picking -2, we're going to get 6. And the first term is our domain. So it's not always x and y, but it's the first term. So the domain of this particular problem would be, so our domain would be -2, 2, it's the first term, 3, and 6. So there's our domain. What is our range? Our range is our output. What do we get after we put in or pick their numbers or whatever we've put in? Well, the range is going to be, well, 6. 6, well, it's always going to be 6. Only output is always 6. So our range in this case is 6. Is this a function? Well, what's the definition of a function? A function is something for every domain, for every input or x value you put in only has one range or one output. So every time we put in -2, we're going to get 6. Every time we put in 2, we're going to get 6. So this is a function. Yes, it is a function because for every input, you only get one output. It's like, let's say you're going to go to Mexico and you take $5, you want to convert that to pesos. Well, every time you give them $5, I don't know what the exchange rate is, but let's say you get $10. That would be an input of $5 to get 10 pesos back. So you know what that is all the time. You wouldn't want to give them $5 one time and get $7 back the next time. That would not be a function because you put in $5 one time to get 10, next time you put in 5 you get 7. You don't know what you're going to get. You don't have a well-behaved relationship. So let's look at the next one here. State the domain and range of the following relationship. Is a relationship a function? Okay, here, so what's our domain? Our domain is 4, 3, 6, and 4. So there's our domain. The first input value, the first number. You can think of it as x, but it's not always. You can use other variables. So what is our range? Well, our range is 6, -1, 6, and 3. Well, 6 is repeat, so we'll go ahead and we'll rewrite this. We don't need to write it in twice. This becomes 6. Well, typically we write this in order. So this would be -1, 3, and 6. Now that's our range. Is this a function? Well, for every input, do we have a unique output? Or in other words, does the first coordinate ever repeat? Well, in this case, let's say if we put in 4, we're going to get 6. Okay, that's fine. But once again, if we put in 4 here, it repeats. The first one repeats, so it is not a function because sometimes you put in 4, you'll get 6. Next time you put in 4, you may get 3. So it's not a well-behaved relationship, and it is not a function. So no, this is not a function. Okay, let's go back up to the problem here now. Use the graph to find the domain and range using interval notation. So what is our domain? Our domain is anything our input values. In this case, our input values is going to be x. So what value of x can we put into this and get a y answer? Because you can see we can pick any x we want, and that'll give us some y value. Well, we can pick any x value because this parabola goes on forever and ever. It just keeps going on out here and on and on and on. So it's infinity. So the domain is -infinity to infinity. Remember, it's parentheses around infinity because we can't bracket in infinity. So we can pick any domain, any x value we want, and we will get a y value out. Now, what is the range of this particular problem? Well, the lowest value we can have is -2. So the lowest y value is -2, and -2 is included, so let's bracket that. So it's -2 to what is the largest y value we can get? Well, as x goes to infinity, our y values are going to also go to infinity. So even as x goes to positive infinity, we're going to get positive y values. And as x goes the other way to negative infinity, this still goes into infinity in the y direction, but the positive direction. So the lowest value we can have is -2, and the largest is infinity. So the range is -2 to infinity. Is this a function? Yes, it is a function because we can do the vertical line test, draw the line, and it only crosses the graph at one point of the vertical line. So the graph's the easiest way to do whether a function on the graph is just to do a vertical line test. So that, yes, it is a function by using the vertical line test. But we can also look at the old, I don't know, let's do the old XY chart. And so we know y is equal to x squared minus 2. So any value of x we pick, let's say we pick -1, well, -1 squared is 1 minus 2 gives us -1. And we could look over here too. We could say if x is -1, we get 1 right there. How about if x is 1? Well, if x is 1, we get -1. And we can see that by putting 1 in here. 1 squared minus 2 still gives us -1. We put in 2, we'll get +2. So if we get in x is equal to 2, we get +2. Or x, sorry about that. If we get x is 2, we get a +2. If we get x is -2, we'll get a +2. So we can look at this, and now we look at this, and is there any of our x's repeat? No, they do not repeat. Every one gives us a unique output. 1 gives us -1, -1 gives us -1. Now our y's here, or our ranges, can repeat and still be a function. It's a matter of whether the inputs or the x values repeat as to whether it's a function or not.